Hello, Namaste, Salam and Sat Sri Akal. Welcome to the navigation video for the A/B testing app. Let me get started right away. So first let's launch the app. I'm going to assume you have zero code login credentials. Please go to the A/B testing app and launch it. So, well, let's see. This is the apps list, the A/B testing app, zero code, and you launch it. So click on this and it will launch. When it launches, it will look like this. Okay. All right. If you go below, you see a download sample text file. Please click on this. And you will see that this sample CSV file, ABC underscore test data, will download to your downloads folder. Then, well, read that in. Let's go here, downloads, ABC test data. So let's put this in. It has come in. Okay. It has come in. Then please go to the data tab and you can see what the data are like. You could upload another data set with A/B testing data in it, but it would be roughly along these lines. All right. Let's see. We have 1, 2, 3 output tabs, 1, 2, 3, 4, 5 input UI options for users. Okay. The first thing we have to do is select the variable defining the variant. Okay. So this is in some sense. So these are the variants. Let me, in some sense, introduce this data set, a background to this data set, so we know what's going on. Yeah. So we saw this 3 output tabs, 5 input controls. We downloaded the sample input file, and we've uploaded it back from the downloads folder, and we saw the data tab. Say we are running 3 variations of an ad. Okay, let's call them copy A, copy B, and copy C. These are called variants. Yeah, it doesn't just have to be for an ad. I mean, it could be 3 different versions of an email header in an email campaign. So it could be variants are the different versions of our promotional material, effectively. Now, users performing some action. So users are browsing some publisher site, say, Times of India, or clicking on a link or coming to a landing page. So these users are randomly shown one variant ad copy. So roughly 1/3 randomly would see A, another 1/3 of browsers users would see B, and another 1/3 would see the variant C. Okay. Now the ad requires users to take some action. Okay, let's say click a link or subscribe to a channel, donate or share their email for a newsletter. This particular action, if users take, then they become converts. Okay, so we would say converted is equal to true. So here these are, so the user 1 has been shown variant C, user 2 variant A, and so on and so on. Okay, there should be variant B also, but there it is. Now, if a user after seeing the ad is influenced and converts, then we will get a true here. Otherwise, it's a false. Okay. We can also measure other things, length of stay or revenue and so on, depending on what the context is. So different data sets can have different metrics, different action sets, different variables. Our task is to see if there is a statistically significant difference between the conversion effects of the 3 ad variants. Is ad A better or ad B better or ad C better, than the rest, so to say. So if A has more conversions than B and C, then A would be better, and so on. Yeah. So we are trying to find out which of these variants, which of these versions is best and by how much. Okay. All right, folks. Now let's select the variable defining AB. The variable is variant. Okay, so which are the versions, the variants? Now we have to select a baseline or a control variant. This becomes our reference. Okay, let's go with A. Just as an example, let's go with A. So A, relative to A, how does B do and how does C do? That is what we will see. So you select your baseline. What is our outcome variable? Now you could choose one of these are continuous. Let's start with a simple case. Let's start with conversion being our output. Yeah. So if a user is converted into a subscriber, let's say, yeah, then our outcome is true, otherwise false, something of that sort. And the positive outcome level we are looking for is true. Okay, so basically true is, it means that the ad has succeeded. Yeah. All right, now we are ready. That's about it. The app is done and it will give us it will calculate and give us the outputs. Okay. So what I will do next is walk you through the various outputs that this main table shows you in the app. Okay, details of the outputs table. The first one we see is conversion rate. It tells us what percentage of the sample shown a variant converted. Okay. So basically this is it. People about, so this is a proportion. As a percentage, it would be 2.41% of users who saw version C, variant C, converted to subscribers. 3.35% of users who were shown variant A converted to subscribers. 5.95% of variant B, users exposed to variant B converted to subscribers. So this bar chart here basically shows you. So C is about 2.41%, A would be about 3.35%, and B is close to 6%, 5.95. The second line is estimated difference. So there it is. Relative to the baseline variant, remember we chose A as our baseline variant, how did each variant do? So our baseline variant was A. Relative to A, well, A didn't show any, A will be 0 because it is the baseline and we are comparing with the baseline. How did C do relative to the baseline A? 2.41 is less than 3.35%. So the estimated difference is negative 0.95%. How did B do relative to baseline variant A? Well, 5.95% is greater than 3.35, and there you have it. This did about 2.6% percentage points better than baseline variant A. Okay, so that is estimated difference. Relative uplift is I convert this estimated difference into a percentage over this. Okay, so 0.95 over 3.35 is about minus 28%. And here 2.6 over 3.35 is about 77.6%. So that's a relative uplift. Okay, there you go. Percentage rise or fall in conversion rate compared to the baseline variance conversion rate. So that's what we have. Now, if I pool the entire sample together, if I put together A, B, and C and calculate an average for the full sample, it would seem that about 3.93% of people who were shown any of the variants, on the average about 3.93%, converted to becoming subscribers. Yeah. So we are calculating for the pooled sample. The pooled sample means all three variants stacked up. Okay. So the users for C, for A, and for B, we are putting them together, combining them into one data set. So we find the mean and the standard deviation for the pooled sample. That's what this is. Okay. So let me show it to you here. Pooled sample proportion is conversion rate mean and standard deviation for the full sample across all variants. Okay. Now we can compute a z-score and corresponding to a z-score a p-value based on the standard error, which is here, this one, okay, which is this one, and we have our conversion rate itself. So our z-score for C, which is this is negative, please see this. If this is negative, then this will also be negative. If this is positive, this will also be positive. And we are getting how significant is this z-score. The idea here is z-score tells me whether what I have here in terms of estimated differences, is it significant or is it just random noise? Turns out, yep, when it comes to variant B's difference with variance A is significant. It's This is significant at 92%, 91% roughly. Yeah, this is significant at 91%. Whereas variant C's difference with variant A is not significant. Okay. So for each of these conversion rates now, I can also build a confidence interval, right? So this 2.41, confidence interval I'm going to build using the standard error will be between 0.01 and 3.81%. The confidence interval around variant A's conversion rate is 1.79 to 4.9%, and that around B is 3.8 to 8%. Okay. That's basically what we are seeing here. So z-score and p-value are shown, CI upper and lower are shown. Okay. So let me quickly summarize. It's a very simple app, and let me summarize, but rather powerful. If you're using anything in an A/B testing kind of scenario, you can upload it here and basically decide which of them has done better. The A/B testing app enables us to analyze the effectiveness of any variants on any outcome of interest. In this case, between A, B, and C, which is the best variant? It looks like it is B. It has a positive, it has positive difference in conversion rate against the baseline, and it's significant also. Okay, so in both cases, both ways, it has done better. The app allows us to statistically test for significant differences, and that is what the p-value is showing us. If the p-value is less than 0.1, ideally less than 0.05, then it means that we have a statistically significant estimated difference. That's basically what it means. Yeah. Okay. Post this A/B testing, we can decide which variant to select after examining relative effectiveness. In this case, obviously, based on conversion rate and statistical significance, variant B is our best bet. Right now, we had a discrete outcome. So we were looking at conversion into subscribers, true or false, for which we chose a positive class. So we were basically saying, this is our, outcome variable is true, false, and the positive level is true. Okay. What if we had a continuous outcome? Okay. We can then specify a zero class. Okay. And in this case, the more negative a variant score, the better it has done. Let me show you. Okay. Suppose instead of seeing whether they converted into subscribers or not, the purpose of the ad was, let's say, revenue or length of stay. Okay. Let's say revenue. Okay. It was, did we make a sale, so to say. Yeah. We don't have a positive outcome level here. You can see all different revenue types are kind of coming in here. So we will choose 0 as our reference outcome level. Now this is not positive anymore. Okay, 0 implies the ad has failed. It has not gathered any revenue. Yeah. So now if you go to outputs, yeah, variant B will be 0. Anything which has gathered output, so about 96.65% of people who were shown the A version, did not give any outcome. That's why it is a 0 outcome. Yeah, about 97.6% of people who were shown the version C ad did not give any outcome. 94% of B's users did not give an outcome. So basically, it means that B has the largest proportion of positive, non-zero outcome users. Yeah. So the more negative the difference, the better the ad has done, better that version has done. And here also we will find a similar p-value. Here also, when it comes to continuous outcomes, we basically have version B doing best. Okay.